So here's what we're learning today. I can convert from one form to another. So there's three different forms. There's standard form, there is vertex form, and there is intercept form. Now, last class period, we talked about how to go from standard form to vertex form. So we're going to interchange between all three forms, and we're going to show why each form is useful and why some forms have more benefits than the other. So each one tells us different information. Okay, so I have some notes out there. These notes go from one form to another. So you can see these notes are from standard form to vertex form. These notes go over how to go from vertex form to standard form. And we've already been doing standard to intercept. So what I'm going to do is I have a copy of this out. I'm going to show that on my document camera. And what we're going to do is I'm going to give you a function. If the function confuses you, you can put that as y equals. It's the same thing. And we're going to go from one form to the other and just talk about what does each form give us, what does it tell us. So, there we go. So let's start off with vertex form. And so to kind of give you an overview, we're going to start off with the problem in vertex form, and we're going to do both forms. And then we're going to start with the problem in standard form and find both forms and then graph it. And then we're going to start off with intercept form and find both forms and graph it. And notice all of these are the simple ones. A is 1. And in your practice, I made them simple. All of them are A is 1. But if we have time on this video, we will also do one where A is not 1. You can see A is not 1. It's a 3. So we'll see what we get through. At the very minimum, we'll get through 3 examples. So if this is what we call vertex form, notice it is in this form. There is no A value, it's 1. So this one is not going to be stretched or compressed. Remember, when A is bigger than 1, we say it stretches. And when A is between 0 and 1, we say it compresses. Another way to say that is it widens. So when I look at this, the advantage of vertex form is it tells us, you'll never guess, it tells us the vertex. And the vertex so this tells us the vertex. And what is the vertex? The vertex is HK. So looking at that, H would be 5, K would be -4. So in this form, I know the vertex is 5, -4. That's very, very, very useful. So what that means is I could go on my graph and I know it's kind of hard to see, but I counted 5 over, I hope. Yes, I did. And I counted 1, 2, 3, 4 down. Yes, I did. So that's the vertex. Now we also know that we have an axis of symmetry at x is 5. That's the axis of symmetry. So what that tells me, it's symmetrical on the left and the right side of the vertex. So I'm going to draw that line real fast. And basically whatever happens on the left happens on the right. And that's x equals 5, the axis of symmetry. All right, well, that's all I really know. Besides, the a value is positive. This is a 1. So the only other thing I know is that it opens up. So I know that this is going to be called what's our minimum. It is our lowest point possible. So our range is going to be from -4 on up. So this is as low as this parabola goes. So it's going to come down, intersect, hit the lowest point, go back up, and intercept. Which is good news because we're going to try to put this in intercept form. So when you're in vertex form and you want to go to standard form, the easiest way, and I'm going to write this as y equals because you guys are used to y equals. All f of x is saying is it's a function. So I'm going to write this as y equals. I'll use the same color. So to find standard form, all you got to do is distribute this out. So x minus 5 squared is just x minus 5 times x minus 5. And then we're going to minus 4. Remember, we are not going to subtract till the very end. Order of operations say we need to multiply first. So we're going to distribute. We're going to take x times x. I'm going to take x times x. That's x squared. I'm going to take x times -5. That's -5x. So I distributed my x. Now I'll distribute the next term, the -5. So -5 times x is -5x. And then -5 times -5 is positive 25. And then, of course, we bring down our minus 4. Combining like terms, well, x squared, there's no other x squared, so I'll write that down. These two combine to be -10x. And then 25 minus 4, 21. So what does standard form tell me? Standard form tells me this right here is what I call my y-intercept. So the standard form, this tells us the y-intercept. So the C is the y-intercept. So unfortunately, my graph only goes up to 10, but I have just found that on the graph, if you go all the way up to 21, which would be around here, which I'm not going to plot because it just doesn't make sense to, the y-intercept is 21. So I guess I could say, let's see if that's 10. So the y-intercept is going to be like right there, a little bit higher. So this is the y-intercept. So this is what we call y-intercept. Also, it's easier if you go from vertex form to standard form and then go to factored form. So I'm not going to start with this form because that's going to be very difficult to factor. So since I already went to standard form, I'm going to copy that down and then factor that. And before we start, I'm going to try to write a little neater. What does this tell us? Well, this tells us the x-intercepts. P and Q are the x-intercepts. So I know I said this already, but if you start in vertex form, it's easier to go to standard form and then intercept form. Don't try to go from vertex to intercept form without going to standard form first. Now I'm just looking, when I taught you how to factor, what multiplies to 21 but adds to negative 10? One and 21, 2 doesn't go into 21, 3 and 7, there it is, 3 and 7. Not 3 and 7, but negative 3, negative 7. So I can write this in factored form. A is 1. These are the easy ones. X minus 3, X minus 7. Now, if I wanted to find the solutions, I would set this equal to 0. And I get X minus 3 is 0, or X minus 7 is 0. So I'll get 3 and 7. So I could go to my graph, and I'm not going to graph it 3 different times. So what that means is I could go to 3, and that's an x-intercept. And then I could also go to 7, and that's an x-intercept. And then if I wanted more coordinates, which I'm not going to do for time, because I want to show you 2 more examples, I would then choose like the number 2 and then plot that on both sides because it's symmetrical. And notice the x-intercepts are symmetrical. This is 2 over, this is 2 over. Okay, so for today, to keep it simpler, technically I should go find more points, but I am going to simplify this and know that this intercepts way up here at 21. Figure is not drawn to scale. Okay. So that's useful. So let's recap what we've done so far. I started off with this form. I found the vertex is 5, negative 4. I plotted the vertex 5, negative 4. I then copied this over and I did what's called the distributive property, and all I found was standard form, which told me the y-intercept, which also I could then copy over here, which then I could factor to find the x-intercepts. So if I start with vertex form, that's how you go to the other 2 forms. Now I'm not going to, on the next pages, I'm not going to write out the benefits every time. Let's say I start you off in standard form. Standard form, and I keep choosing bad examples, all we know from standard form is that down here at negative 12, that's the y-intercept. Okay, so that's all we know. We also know because A is 1 that it opens up. It's going to look like this. And wow, my negative 12 is too far over. It should be like right there. There we go. So the easy one is intercept form, going from standard to intercept. So I'll copy this down. Oh, this is simple factoring. What multiplies to negative 12 but adds to 4? 1 and 12 is 12, adds to 13. 2 and 6 multiplies to 12, adds to 8. But 6 minus 2 is 4. 6 and negative 2. There we go. 6 and negative 2. 6 times negative 2 is negative 12. 6 plus negative 2 is 4. So I get x plus 6. X minus 2. So this is what we call intercept form. And then to find the solutions, I would set it equal to 0. And I get my solutions are x is negative 6, x is 2. So now I can go to my graph, and I'm just going to graph it on 1. Negative 6 and 2. Now there's something very interesting about the vertex, and there's two different ways to get the vertex form. The vertex will always go right down the middle of the graph. The axis of symmetry goes to the vertex. So one way you could do this is you could figure out how many units is it from here to here. And so let's count real fast, and I'll zoom in so you can see it a little bit better. So how many units is it? It's 1, 2, 3, 4, 5, 6. Duh, it was 6 because it was negative 6. So I count 6. And then 2. 1, 2. So it is 8 units. So what that means is, because from here to here is 8 units, and the vertex has to be right in the middle, well, what's 8 units divided by 2? 8 units divided by 2 is 4. So I know the vertex, or at least the axis of symmetry, is at 4 over. 1, 2, 3, 4. So I know the axis of symmetry, 1, 2, 3, 4, right here. Which is that x equals negative 2. Again, how did I get that? From here to here is 8. 8 divided by 2 is 4. So if I go 4 over in either direction, that's where the axis of symmetry needs to be. That also means the vertex is negative 2 something. So how do I find that something? I just plug it in. So I would say negative 2 squared plus 4 times, and actually I'm thinking about it. Let's do it over here. We got space. So my vertex, so I'm starting off with this form. And if you didn't understand what I just did to get the x value of the vertex, I'm going to erase this. There is another way, and it's b divided by negative 2a. So doing that real fast, b is 4, b, a is 1. So that's 4 divided by negative 2 is negative 2. Notice it is the same, negative 2. It's kind of cool, huh? So what I need to do to find the y value is I just need to plug negative 2 in. I need to plug this in to the x's. So y is -2 squared plus 4 times -2 minus 12. Now, you could plug this into a scientific calculator. Desmos has a scientific calculator if you need it. I'm going to go ahead and do this by hand. See, -2 squared is 4. 4 times -2 is -8 minus 12. That's really what is 4 minus 20. 4 minus 20 is what? -16? Well, yeah, this is not a very good example to graph. So I got the vertex is -2, -16. And remember to put this in vertex form, because we still need to do that. Vertex form would be y equals, what's my a value? My a value is 1. You don't have to actually put the 1. And then you would put your h. H is this number. So you'd put x minus -2. That'd be an x plus 2. And then plus k. K is -16. So if I go down here to -2, way down here to -16, that's the vertex. Okay. So it's going to look something like, it's going to go and that's what we call a rough sketch. Okay, it's not perfect. All right, so what did we do again? We started off in standard form. We spent a long time going from standard form to factored form, so that part should have been pretty easy. But then we remembered to go from standard to vertex, you need the vertex. So we did the formula, b divided by -2a, found the vertex, which was -2, -16, and then we plugged in to the vertex form, which says you put your x there and your y there of your vertex, and that's vertex form. I'm going to have to go through the other one super fast. All right, so this one tells us the intercepts. The intercepts are 2 and -4. So I could go to my graph and I could graph 2 and -4. I could then count the distance, 1, 2, 3, 4, 5, 6. So I know my axis of symmetry is going to be 6 divided by 2, 3 over. So 1, 2, 3 over at -1. I also know my vertex because I'm going to need it. My vertex will be -1 something. Okay. Now to get to standard form, it's actually pretty easy. I'm just going to distribute. And again, I'm running out of time here, so I'm speeding up on purpose. So if I distribute that, it'd be x squared 4x minus 2x minus 8. 4x minus 2x is 2x. And what does this tell us? This tells us the y-intercept. The y-intercept's at -8. 1, 2, 3, 4, 5, 6, 7, 8. Kind of cool because this is symmetry. I could also tell you that the other point is going to be right here. Because if it's 1 over there, it's going to be 1 over there. So I'm going to go ahead and plot that point too. That's what's nice about symmetry. All right. Now, if I wanted to, I could have used the formula b divided by negative 2a would be 2 divided by negative 2 times 1, which is negative 1, to get the vertex of negative 1. Okay. Now, I'm going to plug negative 1 into this to get the y value. Y negative 1, because that's the x. And I get y is 1, negative 1 squared is 1. 2 times negative 1 is negative 2. So we have 1 minus 2, negative 1, negative 1 minus 8, negative 9. So I got negative 9. And so now I know h is negative 1. So when I plug it in, it's going to be minus negative 1. It's going to change to a plus 1. And then I'm going to plug negative 9 in for k. And so I could just change that to a minus 9. So my vertex form is y equals my a, number in front is 1, number in front is 1. So I made all of these very simple. In your practice, I kept them simple, but they do get trickier if a is not 1. So you could put a 1 if you want. I will. X minus h. X minus negative 1 would be x plus 1 minus k. All right. Since we have time on this problem, I am going to type all of these into Desmos and show you that they are all the same thing. That's a good way to check your answers. So we started off in factored form. Which was x minus 2x plus 4. Notice those tell us the x-intercepts. And then we converted to standard form. And what does that tell us? That tells us the y-intercept is negative 8. See? And notice they are the same thing, just different forms. And then we converted to vertex form. And notice those are the same thing. And all I'm doing is clicking that to turn it on and off. And what is the vertex? The vertex is negative 1, negative 9. Let's see. Negative 1, negative 9. So while you're doing these, and I'll show you what your practice is, here's your practice. I start you off in a form, and you're going to write the 2 new forms. The graph is already ready for you. I'm pretty sure these graphs are correct. I can't promise, but I mean, try not to look at the graph. Try to use the graph as just a way to check your work at the end. But I start you off in vertex, go to the other 2. Start you off in standard, go to the other 2. And then we do intercept, go to the other 2. So that is your practice. Good luck. I am signing off. Have a good day. Nice to see you all. Bye-bye.